Hi class, we continue our study in chapter 1 talking about linear equations and linear functions. And now moving into section 1.4. And in this section what we're going to do is we're going to talk about the meaning of slope for equations, graphs, and tables. So we'll start with equations, then we'll move in and do some graphs, and we'll end the lecture talking about some tables. All right, so let's start with a real simple example. Suppose I give you this equation, all right? So I say find the slope of the line y is equal to 2x plus 1. Now, many of you might remember from previous math classes what the slope is just by looking at it. But what I want to do is I want to walk you through and derive how we got it. Okay, so first thing what we can do is we can use, to find some ordered pairs, we can use x is equal to 0, 1, 2, and 3, all right, in a table and list the solutions. And then we want to sketch the graph and see what we notice. So I've done this for you over here. Like when you plug in 0 into this, you get 2 times 0 plus 1. Then y is 1. When you plug 1 in, you get 2 times 1 is 2, plus 1 gets you 3, and so on. All right, so if the run is 1, all right, so the run is the change in x. So when x changes by 1 to go from 0 to 1, then 1 to 2, 2 to 3, all right, what we see here is the rise always changes by 2. So the slope is rise divided by run, or 2 divided by 1, which is 2. Okay, so we're saying this is the slope. But you should notice something up here. You see this 2 hanging out here as well. All right, so when you graph the equation, all right, look, you run 1, rise 2, run 1, rise 2, run 1, rise 2, and so on. You're seeing that rise, that slope of 2. So what we can conclude from this is from a linear equation of this form, y is equal to mx plus b. That letter m, the value in front of the x, is the slope of the line. All right, so looking back here, this 2 in front of the x, that tells me that is the slope. That's in the y is equal to mx. So the m here is 2, and that's the slope. All right, let's work another example. So let's take two lines. So are the lines y is equal to, now the slope is a fraction here, right? Because the value in front of the x here is the slope. Y is equal to 5, 6x plus 3. And this line, all right, 12y minus 10x is equal to 5. Are they parallel, perpendicular, or neither? Notice that this second equation here is not in the form y is equal to mx plus b. It's not in that form. Okay, so what we need to do is we need to take this line and see if it somehow has the same slope as this. All right, so the slope of the first line is 5, 6. All right, what we have to do for the second line is we have to take this and put it into the y is equal to mx plus b form. Excuse me. So first thing I'm going to do is I'm going to add 10x to each side, right, to cancel this out. So those cancel. You get 12y. I'm going to rearrange it is equal to 10x plus 5. Next thing I'm going to do is I'm going to divide both sides by 12, so everything by 12. These 12s cancel. The 10 divided by 12 reduces to 5 divided by 6, and the 5/12 doesn't simplify at all. All right, so what I've done is I've taken this equation here and I've transformed it into this equation. All right, well, look at this line. Y is equal to 5, 6x plus 3. This is y is equal to 5, 6x plus 5/12. Well, are they lines parallel, perpendicular, or neither? Like, how do we know? All right, so if you remember from last section, we talked about what makes two lines parallel. And what we see is that both slopes of the slopes of both lines is 5, 6. Right, so the lines have the same slope. So lines that have the same slope are then parallel. So those two lines are parallel lines. You can use a graphing calculator, like I showed you in the previous section, how to do this. If you hit the y is equal to, and you plot the two lines, first one in y1, the second one in y2, you'll see that the two lines look like this, and they are indeed parallel. All right, so let's talk something about called the vertical change property. So for the line y is equal to mx plus b, if the run is 1, then the rise of the slope is always m. So let me go back for a second. So what we're saying here is, right here, the rise is 1. All right, something like this. So it's 2 divided by 1, but we just write it as 2. So when the rise is 1, excuse me, the run is 1. All right, so if the run is 1, then the rise is m. Okay, so whenever you have some m here, Do you ever want to just find another point? You'll see this in a second. You run 1, and then you rise m. If the slope is negative, you still run 1, but then you go down instead of rise because the negative is telling you to negate it, do the opposite. All right. Going on, for a linear equation of this form, y is equal to mx plus b. What does this b represent? Well, it turns out the b is what we call the y-intercept. So it'll occur at 0, comma b. That's where the graph crosses the y-axis. All right, so when you have this equation of this form, y is equal to mx plus b, all right, we say this is what we call the slope-intercept form because it tells you what the slope is, m, and it tells you what the y-intercept is, b. Right? That's incredibly important. So right just by looking at that line, you can say, all right, I know what the slope is. It's whatever the value is in front of the x. And hey, I know where the graph crosses the y-axis, all right? Because that occurs at the whatever the number b is. All right, so suppose I want you to sketch this. I want you to sketch the graph of y is equal to 3x minus 1. All right, well, just by looking at this, you can tell some incredibly important information. You can tell just by looking at it that the slope is 3, and then I said that the y-intercept is whatever occurs here. Well, when there's a negative here, it comes with it. So the y-intercept occurs at -1. All right, so note the y-intercept is 0 because that y-intercept occurs when x is equal to 0. So 0, comma, -1. And the slope of this line is 3. All right, so the first thing I want to do if I want to graph this, I'm going to plot the y-intercept. Now, I'm going to use the slope then, all right, to see what the next point is. So I'm going to start at the slope, start at the intercept that I just plotted. And then I'm going to run 1 unit, because it's rise divided by run, or 3 divided by 1 in this case. So run 1 unit, and then go up 3 units to the second point. I'm going to show you that on the next slide. And then the next thing you're going to do is you're going to sketch the line that contains these 2 points. All right, this seems a little weird, but let me show you exactly what I'm doing. So first I'm going to do is I'm going to plot the first point, the y-intercept 0, comma 1. Since my slope is 3, I'm going to run 1. So I'm going to, from the y-intercept, I'm literally going to go whoop, over 1. And then I'm going to go up 3 points on the plane. So here, and then I'm going to go up 1, 2, 3. Boom. And there's my second point. So I started at the y-intercept. Then using the slope, I run 1. And then I go up 3 to get the second point. So my first point is 0, comma, -1. And then all of a sudden, I got moved to this point, 1, comma, 2. Well, that tells me this. Once I get the 2 points on the line, all right, I can literally just go whoop, and draw the line right through those 2 points. So it's a very, very simple trick to be able to plot the second point on the line using the slope and the intercept, and then draw the line right through it. Okay, so just to go over what we did here. To sketch the graph of a linear equation of this form, y is equal to mx plus b. You plot the y-intercept, whatever 0, comma, b is here. Then you use rise over run to plot the second point. So like in the previous example, it was 3 divided by 1. So I went over 1, up 3 to get to the next point. So run 1, up 3. Once you have that second point, sketch the line that passes through those 2 plotted points, just like I did here, just straight like that. All right, so just a warning here, before we can use the y-intercept and the slope of the graph line, we must always put it in that y is equal to mx plus b form. That's the only way you can use this. You have to put it in that form. All right, so let's work an example just in general form. Okay, so determine the slope and the y-intercept of the graph of ax plus by is equal to c, where a, b, and c are constants and b is non-zero. So just kind of replacing a, b, and c with numbers. So I want to find the slope and the y-intercept of the graph of 3x plus 7y is equal to 5. All right, so in general form here. If I want to solve to get y by itself, right, first thing I'm going to do is I'm going to subtract the ax over. So these are going to cancel. So what I do now is I put the x in front. So this minus ax just goes in front because that's what we're used to seeing, the x in front. Then I'm going to divide everything by b. So these cancel like that. And it looks like I can simplify this to, if I started with ax plus by is equal to c, y is equal to, this just becomes minus a divided by b, then your x, plus c divided by b. So if you're given an equation in this form, you can just simply use this formula here. It's telling you, well, the slope is going to be minus a over b, and the y-intercept is going to be c divided by b. Right, so there it is. The slope is minus a over b, and the y-intercept is 0, comma, c divided by b. So looking at this, all right, let's find the slope and y-intercept of this graph. 3x plus 7y is equal to 5. Well, we know that 3 gets substituted for a, 7 gets substituted for b, and 5 gets substituted for c. So using the result from problem 1, all right, remember, it's minus a over c is the slope, or a over b, excuse me. So it's minus 3 divided by 7, all right, and the y-intercept is c divided by b, where 0, comma, c is 5, divided by b is 7. So you can use this quick trick to work the problem out instead of doing the algebra for it if you wanted to. All right, so let's talk now about the slope addition property. For a linear equation of the form y is equal to mx plus b, if the value of the explanatory variable, right, which is x, increases by 1, then the response of then the value of the response variable, which is y, changes by the slope of m. Right? So what the slope is telling us is, hey, when x increases by exactly 1, how much does y go up? That's what the slope tells us. All right, so I've got 4 tables here. So 4 sets of points are described in the tables below. For each set, describe whether there is a line that passes through every point. If so, find the slope of the line. If not, decide whether there is a line that comes close to every point. All right, so what you're going to have for a line to go through points like this is you're going to have a constant rate of change, or a constant slope. All right, so kind of looking at these. All right, let's take a look at the first set, then we'll do the second, third, and fourth. All right, for set 1, when the value of x increases by 1, what we see here, so x is going up exactly by 1, we're seeing that y falls by -3, or it goes down. Right, so when the value of x increases by 1, the value of y changes by -3. So a line with slope, because that's how much it's changing, -3, passes through every point. Now look over here. When x goes up by 1, 12 goes to 17 goes up by 5. 17 to 22 goes up by 5. It looks like it's going up by 5. So for set 2, when the value of x increases by 1, the value of y changes by 5. So therefore, a line with slope 5 is going to pass through every point here. For slope 3, or excuse me, for set 3, when x changes by 1, look what happens. 3 to 6 goes up by 3. Then this goes up by 6. Then this goes up by 12. And this goes up by 24. So it's changing by a different amount. So when the value of x increases by 1, the value of y does not change by the same value. All right. Further, a line does not come close to every point because the value of y changes by such a different amount each time the value of x changes by 1. So this we'll talk about in later sections. It looks like it's some type of quadratic or exponential growth to the value of y, but we'll get to that. All right, look at set 4. This is weird. X is going up by 1 every time, but the value of y is not changing. Right? But is the value changing by a constant number? Yes, it's changing by 0. So for set 4, when the value of x increases by 1, the value of y changes by 0. Therefore, a line with slope 0, remember, slope 0 means it's a horizontal line, passes through every point here. All right.